Ladies and gentlemen, please take your seats. We'll begin in 5 minutes. Ladies and gentlemen, please take your seats. The program will begin momentarily.
The SubT Challenge is an open competition where teams from all around the world can compete, awarding high performance at each of 3 circuits: human-made tunnels, urban underground, and natural cave systems, in addition to prizes in a final event combining all 3 subdomains. These deep, Dark, dangerous, dirty, and largely unknown spaces present substantial challenges for warfighters and emergency personnel as they respond to threats from adversaries or disasters. We know that the technologies that are currently available to help those first responders and warfighters have certain gaps, and we're interested in finding breakthrough technologies to totally transform how we can operate in these environments. All the teams brought, something different approaches, different strategies. When you take robots out of the comfort of the lab and bring them out into the real world, they face a number of challenges. One of the fascinating things about working in robotics is not just about the robot, it's about the people. That human-robot interaction and the kind of the synergy that comes from interacting with these robots. We've seen the ups and downs, we've seen a lot of new discovery, a lot of robots do a lot of really interesting things. That's why I think field robotics is such a demanding but very important attribute, and we certainly stress test these robots here at SubT. The excitement that these teams are bringing to the table has been phenomenal. You can tell that they're really enthusiastic about really solving these hard problems and making an impact. I think that takeaway continues to give me good reason to want to press forward with these types of challenges.
Ladies and gentlemen, please welcome to the stage DARPA SubT Challenge Program Manager, Dr. Timothy Chung.
Oh, wow. That's great. Thank you. Can you believe it? This journey that we've been on, we made it. We're here. Congratulations, everybody. I am so pleased to be here and share this moment with all of you here and in the practice areas. I'm just thrilled at the success that we've been able to demonstrate, not just today or yesterday or the past couple of days, but in fact the many years that I know that led to this moment. So again, congratulations to everybody. I think it's just been phenomenal. So today we're going to have a chance to talk a little bit about where and how, why we're here, and I'm really excited to get to our main thing, which is our awards ceremony. So to get to that point, I think we'll share a little bit. So many of you had the chance to go and see that final event course. I've already heard from some of you how amazing, terrifying, impressive some of that course is, and I think the bottom line here is that was all done for you all. We wanted to find a way to challenge, raise the bar, and you all rose to meet that challenge, and we're really excited. And again, that course is all about you all. So for those of you who haven't seen it in its full picture, here we go. This is our course. We spent many months, years planning it out just to make sure that it hits the mark, make it DARPA worthy and DARPA hard. What I can show you here is that we've gone ahead and designed elements of this challenge course to hit a number of different technology buttons that you've all been able to witness. What I'm showing you here is how we created not only this world for the systems competition, but was able to turn it into that virtual world as well. And again, the continuing theme is how can we bring virtual and systems together so that we can accelerate how that technology gets developed. And you can see how we've been able to merge, overlap systems and virtual in seamless fashion here. So very excited to be welcoming systems and virtual all together here today. Showing a little bit more of those virtual worlds, the diversity of the types of environments we're interested in. You saw in the systems final course how we broke that up into different personalities or different flavors of course elements so that you can understand and test the different attributes of the technologies that we're interested in, and the same went for the virtual competition. Here you see, and those of you might remember, the NIOSH mines and the Satsop nuclear power plant, testing once again how we can take technologies and environments and bring them into the virtual right alongside our systems environments. And so just to highlight some of the performances, one of the things that we like to talk about, it's not all about getting good maps. Of course, you need to generate good maps, but it's about being able to go and find those artifacts, as many of you have been able to do incredibly successfully. So highlighting some of the maps that we're seeing from DARPA to kind of be that sufficient necessary criteria to be able to go out and find those artifacts. Just wanted to share the great performance from all of our teams in the systems competition. And so, as per tradition, I'm excited to highlight a number of superlatives that provide context for accomplishments throughout the competition, and I'll start with the virtual competition. So the single most accurate artifact report goes to Team Robotica in the virtual competition. Congratulations, Team Robotica. They were able to highlight their artifact, finding this artifact, this backpack, to within 5 centimeters. I mean, this is where we've come from all the way back at Styx and 3 years ago to where we are today. The next superlative goes to CTU Krasnor for the most active SubT virtual testbed contributor. Congratulations. So this highlights one of the tenets of the SubT challenge. We are a community, as you have all seen, and the ability to contribute back to that community has been something that's continually enriched the community writ large. And so we have our key contributor here. Since the announcement of the cave circuit pivoting to only virtual, we saw CTU Kras's team join the cave circuit, and in doing so was able to contribute second only to the developers themselves, the number of pull requests to feed and grow the code base associated with the virtual testbed. They're also able to contribute a virtual model for the spot, which we know many of our teams here could be making use of as well. And so that kind of contribution is what will continue to allow our community that we've created here to thrive. So congratulations to CTU Krasnor Lab. Courageous Climbers goes to Team Barks. This is the team that was able to climb the most, traverse the most levels, transit verticality and conquer that the most. Let's congratulate Team Barks. And so for these virtual models to be able to navigate verticality, to conquer verticality in this cave-like environment, going nearly 2 kilometers in up and downs, to be able to do that with their team of UGVs and UAVs, that's a remarkable accomplishment and highlights how critical being able to conquer the verticality of these types of challenging environments absolutely is. So congrats again to Team Barks. And want to share that Sodium-24 Robotics created the largest point cloud map submitted to the SubT virtual testbed infrastructure. So congratulations to Sodium-24 Robotics. As I said earlier, it's not about the best map, but it certainly helps if you have a good, solid map. And so here we have Sodium-24 at SubT Central. That's one of our virtual worlds, submitting over 48 million points for the SubT virtual testbed to ingest, which is really great. And I think this highlights how the ability to process large volumes of information and dissect it and be able to present that in a meaningful way has turned out to be one of those impressive contributions across the board. All right. So now I'd like to share some superlatives for the systems competition. This is another opportunity to showcase some of the impressive contributions that you all have made. Once again, the single most accurate artifact report goes to Cyro Data 61. Once again, we see artifact reporting, and we know how hard it is to maintain that solid map and localize in these really challenging environments. And SARO Data 61 coming in less than 5 centimeters to be able to locate this tiny little drill that's hidden in our core. So congratulations to SARO Data 61. Our next superlative, down to the wire. This is one of our favorites, right? This is for the team who submits the artifact report and gets it scored with just keeping us on the seat of our pants, and that goes to Team CoStar. So here we are, anxiously awaiting, counting down the minute, seconds, and right at the buzzer, basically just about a minute left to go, they're able to score this final point, which is great. Oh, actually, yeah, less than 9 seconds remaining. The most sectors explored. So many of you have seen how we've been characterizing the different sectors of these environments as a representation, as a surrogate for how well you've broadly explored this environment, and that goes to Team Explorer. Congratulations, Team Explorer. What this highlights is that the ability for a team of robots to conquer these 3 subdomains and do so in good fashion. There are only these 2 small segments of tunnel circuit area, tunnel subdomain that were missed. Everywhere else, including the big open caverns all the way to the really treacherous cave sections that many of you went on tours this morning, were able to witness. So congratulations to Team Explorer. And then finally, our fastest artifact report. This goes to Team Marble. Congratulations, Team Marble. This is all about, right off the starting gate, how quickly can you return that actionable situational awareness? And Team Marble was able to get in there, Spot goes down, takes a look around, and was able to, within just the near first minutes or so, be able to find that power drill at that entrance. That's what we're talking about, being able to provide that accuracy alongside the speed that's so impactful for our end users. So congratulations, Team Marble. And so at this moment, I'd love to invite my boss up to stage, the director of DARPA, Dr. Stephanie Tompkins, to help me present the awards this afternoon. So just to kick things off in our virtual competition, the last bit of scoring results to share was for that World 8. Once again, that World 8 was in fact our systems final course transformed into that virtual representation. And so at the end of those 3 runs, those 3 replications for this particular world, here's the lineup of how these teams scored. And this leads us into our final results, which I can kick off by highlighting our top place finishers. In 3rd place, for $250,000, and I welcome you to come up to stage to receive your recognition. For $250,000, 3rd place goes to Team Coordinated Robotics. Please come to the stage. Thank you. All right, let's get your photo. There you go. Congratulations.
Gorgeous, right?
Good job. All right, thank you very much, Kevin. Good job.
Congratulations. Pretty amazing job. Can you carry it back?
Yeah. Great job, Kevin, great job. Next up, in 2nd place, for a $500,000 prize in the virtual competition final event, we have CTU Krasnor Lab. Welcome to the stage. Thank you.
Why don't you guys hold it? I'll get out of the way.
Martin, may I?
Oh,
There you go. You got to hold that too.
oh, it's hurt.
Yeah, of course. All right, let's congratulate them once again.
Congratulations.
Thank you. That's a large check. All right. All right, and the winner of our first place virtual competition, SubT Challenge champion for the virtual competition with $750,000 goes to Team Dynamo. Joining us virtually. So in true virtual competition fashion, Team Dynamo is joining us virtually, so we'll be looking forward to sending these off to Team Dynamo. Congratulations to Team Dynamo once again. All right. So the total roundup for the virtual competition, as you see, stacked up here, and looking forward to sharing these results live out there. Okay, the moment we've been waiting for many of you here as well, the systems competition top place finishers. Third place of the systems competition SubT Challenge final event with $500,000 goes to Team Marble. Good job, Team Marble. Welcome. Chris? Yep.
Oh, thank you.
Here, how do you guys take this? Yeah, get your photo.
Congratulations, Team Marble. So it comes down to our top two finishers. At this point, I have to say that with two teams scoring 23 points, we had to invoke the tiebreak rule. As a reminder, the tiebreak rule is the earliest time that the last artifact was successfully reported. We had that one run, and it all boils down to about a minute difference between that last artifact reporting. So with that, our second place $1 million prize for the SubT Challenge final event systems competition goes to Team Sarah Data 61. Welcome. Thank you. Diana. There you go. Congratulations.
Thanks a lot, man.
Yeah. You gotta get in the middle. Your photo. All right. Great job. Congratulations, Sarah Data 61. And of course, all that remains is the champion of the SubT Challenge final event systems competition for $2 million goes to Team Cerberus. Welcome to the stage. Congratulations. Congratulations.
Let's take it. Here you go, come on.
Take a picture. All right, congratulations, Cerberus. What an amazing finish to the SubT Challenge final event. This journey that we've been on for so long, I think, has shown that we can really take what might be impossible or thought to be impossible and turn that into reality here and make it possible. So congratulations to everyone. Super proud of everyone here and excited to keep things going. So here's the final results, including that tiebreaker. Thanks for providing all of that excitement to everyone here. And I also want to share that, as many of you know, in continuing the development and advancement of these technologies, DARPA will continue to release all of these types of data products that you can make use of to continue the momentum that you've built up to date. So whether it's the virtual testbed repo and being able to share all of the resources from the virtual side, all the way to the ground truth data that you witnessed as on your course tours, being able to make use of that ground truth data, as well as the fly-through videos, as well as all the course walkthrough videos that you can take a look at and, again, further develop your approaches to conquering the underground domain. And so I want to say thank you to everyone here. It's been an amazing privilege to witness the birth and growth and vibrancy of this SubT community. In recognition, as you know, we'd love to share our SubT Challenge challenge coins, which I have ready for you at the registration desk when we're done here today. So congratulations to everybody. Let's do a big round of applause for all of us. Thank you. So just to highlight our community, I want to ask Dr. Tompkins to just say a few words here. Thank you very much, Dr. Tompkins.
Thanks, Tim. So I'm going to echo everything Tim said and thank all of you. And let's just take a moment first, and let's put our hands together for the program manager of the DARPA SubT Challenge, Tim Chung. A little glimpse into DARPA's world. Tim came in with a vision, which all of us inside DARPA thought was crazy. And then he communicated that vision to his internal team, which of course grew and grew and grew. All the people who had been part of the support structure, the communications process, the planning, the endless nights of work. They all thought it was impossible too. But let's have a round of applause for everybody who has helped put together every aspect of this challenge and to make Tim's vision a reality. And then let's have a round of applause for our stakeholders and our transition partners who helped Tim understand what was really important. You can get very excited and very creative when you're designing these challenges and end up with something that might not actually turn into a real solution. And Tim and his team worked tirelessly with all of you who were here and many who aren't to help understand what you really needed and what you cared about, so that all of the things that you saw here today and all of the results of this overall challenge, we hope will ultimately drive towards you and your teammates' greater safety and security in the future. So a round of applause for all of the transition and teams and stakeholders. And finally, our competitors, all of the competition teams. I have heard some of you say off to the side, and some of you say directly to my face that when they first heard about this, they were absolutely positive it was impossible. So thank you for ignoring your gut feelings and diving into this competition and proving to all of us that it's not impossible, it's not just possible, but as Tim has mentioned, it's now a reality. And we have a lot of work left to do. These things move in uneven paces out into the real world. But I want to thank you for everything you have done to get us this far from impossible to highly probable and very close to practical real-world reality. So thanks to all of our competitors. And so on behalf of DARPA, my thanks to all of you as a whole. This is how we work. We're not done. And so what I ask you all to do now, as you go off back to your respective homes, think about where you were 3 years ago. Think about where we are today. And think about where we might be a year from now, 3 years from now, 5 years from now, in actually securing the safety of our first responders, of our special forces, of all of our military operators that put themselves in harm's way for the rest of us. And think about what our role is in order to make that next step towards inevitable reality actually work. So we'll keep the fight going. Thank you for being part of this DARPA experience. And be safe and be well, all of you.
Challenge is about developing and defining the problem, not about defining the solution.
This challenge has the opportunity to create that environment for innovation.
I think that the toughest thing academically about this is having multiple robots work together with very limited human interaction.
You can't just have one thing work, right? You have to have 5 different things simultaneously working. And getting to that point is extremely non-trivial, but I think that that's ultimately the real value.
We love this challenge because it allows us to emphasize on the hardest problems in robotics at the moment in mobility and autonomy, and emphasize on how to solve them.
We think that the virtual is a chance to showcase ourselves.
Clearly, this is the world's top research group, industry group, coming together to solve this unique challenge.
And welcome to DARPA's Subterranean Challenge, the final event.
These are the Super Bowl of the engineering and scientist community.
A lot of work is really what it comes down to.
It's been a long and hard journey for the last 3 years.
Doing what we do and actually going out, seeing where the theory meets the pavements, it's world-class education.
There's a lot of knowledge in this cave.
When we think about what we started out with at the beginning of this competition, there's going to be a bunch of different applications that are opened up as a result of this.
Being part of the family of underground robotics experts is a huge part of the overall fun as well.
I think robotics already has and will continue to improve the quality of life for everyone.
I think this competition in general is really putting a mark on robotics community, AI, and autonomy, and making a really big push forward that we are going to see its impact for years to come.
Ladies and gentlemen, the SubT Summit will begin in 2 minutes. Ladies and gentlemen, welcome to the SubT Summit. Please welcome to the stage broadcast host Cameron Irwin and program manager Tim Chung.
We're getting some laughs. Want to go here? Perfect.
All right.
All right, well, you all take your seats. I am going to ask all of our virtual competition representatives to come on up to the stage because it's time to start getting into some conversation. So all of you virtual competition, there they are. Come on up.
Welcome.
And you each have a microphone in your chair. When you speak, just do me a favor and make sure you hold that up close to your chin, just so we can make sure we hear your voice perfectly. And then also, once we begin this conversation, I'm going to open the floor, as we also, of course, have some virtual leads coming in as well virtually in our back part. But again, if you are going to answer a question, do me a favor and just introduce yourself on the first part. Sound good? Awesome. All right. You ready to go?
Let's do this.
All right. Well, I guess the first thing coming from me, from the virtual side of the competition, the fact that number 8 ended up being the actual course we see here, how important is that to see those two things merging, the virtual and reality? And again, I'll open the floor, and whoever would like to answer first can go. Go for it.
So hi, I'm Dan Riley. I was the team lead for the virtual portion of Team Marble. And our goal with virtual was to really stress our systems in the virtual world to see how that could help us in the systems competition as well. And so when we saw at the end here today that we actually got the virtual world and got to see how we performed at the same time, that was great. And so it was actually really exciting too to see that our fully autonomous solution was about the same as what we had in the systems competition. And the big difference was we added the human operator in the systems and we're able to get a little bit further in. So that kind of helps to show some of the differences between the virtual and the systems, I think.
Well, you speak to the things that you were able to accomplish, but for some of you others, what were some of the things you were able to accomplish that you're really proud of through the virtual competition? Go for it. All you.
Yeah, hello, my name is Martin Soska. I'm lead of our subdivision responsible for drones. So sorry, but now I will mainly reply regarding the drones, not the ground robot. And our team lead, Tomáš Svoboda, will do it for ground robots in the next table. Gotcha. We were, at the beginning, we wanted to, we had a drone with simple LiDAR, which was not enough to precisely localize the artifacts, and also the flying time was bad, and the size was too big. So we wanted to design a drone which would be capable of flying longer, be smaller, and carrying much heavier sensor. So it was almost mission impossible, but at the end we succeeded. My great hardware team did it, and I'm proud that this drone was at the end used by almost all of the team. So we could see the MRS logo, which is logo of our group everywhere, which was really great, and we really enjoyed that moment the most.
Absolutely. I believe it was that X500 we saw throughout the entire
exactly
competition, right? And how many of you actually ended up using those? Raise your hand if you were one of those. There you go. I know Kevin was. Yep, another one as well.
So even we are open sourcing all the software, and even we have been open sourcing the hardware. So this is an offer for all the teams using that drone. If you want to have a real experiments with that platform, even we can build a platform for you if in case of cooperation. So please just send me email and you can try that platform in real.
Yeah, that's great.
Anybody else sharing some accomplishments that you're proud of throughout this? Go for it.
Yeah, I think one of the great things about being in the virtual competition, we were really interested in large multi-agent teams, and so because they don't have to be set up and they are all fully autonomous, being able to launch so many vehicles at once and really working out, if you have 5 vehicles and they're all talking to each other and they're all collaborating, how does that change everything? So that was something that was really useful for us in the virtual side.
Yeah, I mean, I think the idea of using multiple robots is something that you've all taken advantage of. How did you think about the multi-robot strategies? What kind of approaches did you think about when you were composing your teams?
Go for it,
Kevin.
I'm Kevin Knadler, Coordinated Robotics. One of the big strategies we thought about was trying to divide and conquer. And so really you didn't want the same robots going over the same area all the time. That wouldn't be useful. And so how could you divide the area up and split it up? And so that was one of the big things we were happy about, is being able to do that. And then another part of that was our ground robots went in and laid out a network of communications nodes that the aerial robots could use. And so those were the overall strategy of how we had the robots work together.
And Hilario, I'm going to send it on over to you virtually. Check in with our virtual team leads as well. Hilario, what are some of the things that you were able to take away from, apart from that massive check from the virtual competition?
Well, I mean, this competition has allowed us to validate so much of the things that we wanted to do in a future project, which I would love to talk to you about later. And regarding having the simulation and the real hard physical world at the same time, it's fantastic because it really has a lot of value to close that sim to real gap, which is a really hot topic in research right now.
That's amazing. And then Wolfgang, I'm going to send it over to you from Flying Fishes, and I can see the team members around you as well, a little bit of an image there. And I know that this is a family affair for you guys. I mean, what was this like to be able to enter this competition and work alongside your family?
It was really a nice thing that we all together could do this, and we really liked to be part of this challenge. It was very hard for us because we are not so known about the robotics, but it was really a nice challenge, hard work for us, but as a family affair, really a nice event for us.
I love it. Now, I'm actually, go ahead. Oh, you
Sure. No, I'm really curious. So I've got all these questions that I'm excited to ask you about. So as you were practicing, making use of the simulator and whatnot, what were some of the things that was really challenging for you all? I'd love to hear what tripped you up, I guess.
Yeah. I'm Neil Johnson from Team Colembala. One thing that we noticed is that a lot of times you get rid of the easy bugs right away, but the other bugs that show up when the robot's been running for 15 or 30 minutes, and when you simulate that, it can take 4 or 5 times that long. So it takes a lot of infrastructure to address those concerns and figure out what went wrong 30 minutes into the run. That was a big challenge in the simulator.
Yeah, I think that's interesting. It highlights that you need to put these in the types of conditions for the durations that you'd want to have them operating in, and that's particularly hard when sometimes those tests last many, many hours. Yeah, I totally get that.
Get that data.
Go for it, Malcolm.
I'm Malcolm Stagg of Team Sodium 24 Robotics. I also found that the amount of data was a lot to deal with, and I spend a fair bit of time developing an analysis tooling so that I could wade through all that.
Yeah.
Well, and that's a great point you bring up. The amount of data you now have heading in. I mean, what's the next step for you guys in terms of identifying? And you're all there's the chuckles going on. So I know there's a lot of research even still to be done, even though the virtual competition is finished. I mean, how much time are you going to spend after this, even going through it? Looks like go for it.
Yes, yeah. Still, the reality gap between the simulation and real system is there. So we have to work more on more precise sensors, mainly the communication, for example. The model of communication was not perfect even in these worlds or in the simulator. So we have to work much more in these aspects to be able really to test everything in simulator and then run it on the first time in the real system. So we are using regularly simulators in several other projects, like flying far from obstacles with GPS. This is already done well, so we can really simulate everything before. But once you are flying in such a complicated environment as is all the worlds, then the reality gap is still there. And we could see it also today or in these days where our drones were flying in simulator, but in real system, in the same world, the operation was limited.
Yeah. Well, can you speak a little bit about the types of risks that you might not be wanting to take when you're dealing with physical hardware, but the risks that you might want to take when you're doing it in simulation? I imagine that you can expand the types of things that you're willing to try out in that virtual setting. Anyone have any thoughts? Yeah.
Yeah, I'd say it definitely really sped up our ability to work, especially in like the urban environment where there were a lot of pitfalls. We were able to just go right in there before we had our pitfall detector done and just be like, oh well, some of them will fall off and we'll figure that out later. So we were able to do a lot more development parallel to each other, whereas working on real systems, you really have to make sure that those safety features are in place first before you can move on.
And I feel like we need to do a little bit of a check-in with Zurka also from Team Robotica, so we'll send that question on over to you as well.
Yeah, hello, I'm Zurka from Team Robotica. So what we observed is similar to what the other competitor said. I'll give drones as an example. We know that they tend to be both fragile and dangerous if we put around them. You could see, for example, that we were using drones heavily in virtual competition, but still not so much in the real world. So, among other steps, we had take the drones in the air, in the real world.
Now, one of the other elements I think that was themed throughout this entire competition and said by not only the virtual leads, but also the systems leads is the constrained passageways and how narrow everything was. When you submit those solutions, you're completely hands-off. So once you started to realize how small it was, once we got into World 8, and Neil, I see you shaking your head, yes. Mm-hmm. I mean, were you starting to get a little nervous, a little concerned once you realized, wow, this is getting tight?
Yeah, I'm somewhat embarrassed to talk about it, but I think that tripped us up a lot in the final event, where I think we just had things tuned not quite right, and so we had trouble getting some of these narrow corridors, and it was hard to balance to know what challenges we needed to address the most, and we kind of set that one aside and didn't think it would be as big a deal as it was. So.
Did any of the worlds surprise you at all once you started to see them pop up with 8 different ones having to face off against each one? Did any element surprise you?
I think we were surprised, and we really enjoyed seeing the very open sort of box world, because our solution is really interested in finding open spaces and moving through open spaces. And that sort of world where it was mostly sort of one large open space was something that we hadn't seen a lot in the practice worlds we had access to. So I'm really excited to get the data back from that and see how our solution held up in that large space.
Sure. I think just what you're speaking about, the idea that these environments might present very diverse characteristics, and so for you to be able to design approaches that can handle all of that, that's one of the great things about the virtual competition, of course. Were there any types of areas or attributes, confined passageways, open passageways, anything in particular you feel like you tuned for, like straightaways or long corridors or anything like that, that you was like, oh, I hope DARPA gives us long corridors or something like that?
I know we were actually really excited about the constrained passages. Okay. One of the things we worked really hard on was having a solution that was very size adaptive and sort of non-grid based. From some of the earlier rounds of competition, that was something we fell down on very early in the program. So we got really excited about seeing those really big dynamic ranges in terms of space, because that was something that our solution was really geared towards.
You know, one of the interesting elements to me is the makeup of each of your teams, right? Whether you have a large crew behind you or maybe you're just a one-man team. So as a one-man team, what are some of the things that you were able to do or made it even maybe more challenging or less challenging to be able to approach a competition like this? And Malcolm, I'll start with you.
Thank you. Being a one-man team had a lot of challenges in terms of trying to manage the time aspect of things, and kind of just the main thing that I found was important was trying to prioritize all the tasks that I kind of had to do. So there's things that I would have liked to add, but didn't, just because of the time aspect. But being a one-man team, did have some advantages too, because then if there's kind of something that that I want to just try and see how it works, there's really nothing stopping me from just.
I love it. I love it. So I'm going to go over to Kevin at the same time, and we saw you develop even further, starting with the UGVs, then adding in the UAVs. So how were you able to continue to kind of add on to that solution through each of our virtual competitions?
Yes.
Oh, I was going to go to Kevin first, but well, Kevin, go ahead. We'll come back to Malcolm.
Okay. No, so sort of incrementally improving the solution, really, you have to step back and look at it and say, well, where is the solution not performing? And so, for example, one of the things I changed is I changed from my image recognition for the finals, as my existing image recognition worked okay, but had a number of false positives. And so with the reduction in the number of guesses, I had to reduce the number of false positives that I could submit. And so incrementally identifying those areas for improvement is really the key portion of that to move forward.
Sure. So, the one-person team, but now there are other teams that had interns and students. How did you leverage interns and students as an example as any part of your team to gain some insights or leverage? Neil, any thoughts?
Yeah. Tim is familiar that we used a lot of interns on our program, and there's pros and cons to that. One of the pros is that we have a team that's getting more and more familiar with the system, but a con is that they go away after a short time, and it's hard to have that continuity that you need on your team. So there was a mix of blessings and curses, but in general, I'm really glad that we used it as an opportunity to train new people.
And I'm going to, go for it.
If I can, yeah, part of our team is composed from several or lot of master students and bachelor students even, and PhD students. And I like the competition like this, that it's really going beyond the edge of the current research. So these people are really able to publish results of this competition, of results of their work in the best journals, robotics journals, which is our work, in fact. So for that, I really congratulate you that you really were able to push us beyond, so, which is great.
So how much development has actually taken place for each of you and your teams? How much have you learned through this journey? Neil, go ahead.
We've learned a tremendous amount. We've learned a lot of things that don't work, but we've learned a lot that we didn't know about before. For example, we hadn't really dealt with SLAM algorithms at all before this event. The same goes for doing neural net recognition of artifacts and that kind of thing. It was very new to us. And so we've come away learning a lot and how to put all those pieces together to make a system work.
Yeah, some of you started from day one, some of you have joined along in the virtual competition. What do you think is the biggest jump that you've been able to make from your first entry and contact with the virtual competition to what you presented here in the final event?
At the beginning, we had a set of single robots, in fact. So they were working kind of cooperatively, but in fact not cooperating. Mm-hmm. But at the end, we achieved to have really multi-robot system. Cooperation of ground robots, flying robots. They were really sharing maps. They were sharing the goals where they have to go, the frontiers. So at the end, the system was really multi-robot, which was our main goal, and this I like the most.
Sure. So to follow that up, there are folks who might say, "Hey, coordinating these robots, there's a lot of overhead. You have to deal with bad comms," which certainly is the case here in SubT. There's additional computation. How did you decide that coordination amongst your robots is the way to go here? I'm really curious to understand, did you have to ask yourself, is it worth the pain of having to get these robots to coordinate? Yeah, Dan.
Going back to our systems, we didn't join the virtual until later on, basically because CAVE was canceled, right? But we had already been doing all of our coordination and our planning algorithms in simulation before, which was why it was kind of easy for us to transition right away. And because we didn't have enough robots to do coordination in real life for a long time. Mm-hmm. So the best way to do that was in the simulation environment, and where we could not worry about them crashing or getting in the way of each other. So we spent a lot of time doing that long before we even joined the virtual competition. So once we joined virtual, then the coordination was already there.
And I'm actually going to snag it real quick because I'm curious from Hilario's perspective, because he joined in just at the cave and all of a sudden is also now in the finals. So how quick was the jump in, the sprint to get a part of the Subterranean challenge?
So I would separate my development in two phases. When I jumped into the cave, it was a huge experimental phase, which I had to discover what was the right solution to implement. So a lot of development, and a lot of discarding, a lot of algorithms and techniques. But once it was set up, I started developing, and through the finals, it was just a continuation of the work plan that I didn't finish for the cave circuit. And actually, I didn't finish all the developments that I wanted for the finals. So I would separate those into those two chunks: experimental phase, and then the plan ahead and just pure development.
Yeah, I mean, I think being able to jump right in and then accelerate how quickly you can develop, I think that's part and parcel with the virtual competition. It's really cool. Is there a particular pace? I mean, did you find, hey, you would do this every night or every weekend and you're kind of developing code that way? Or is this a 24-hour coding session in those cases?
Good question, Tim. It was 120 hours a week for at least a year and a half.
Yeah.
And it looks like Wolfgang's shaking his head as well. Wolfgang, do you have something to add?
It's similar to Hilario. We needed or used much time, and so also free time we spent programming, testing, and we also had some stuff we wanted to add and did not finish all our tasks we wanted to do for the finals. So I can feel with you. It was the same with you, but you had a better result than me. So congratulations to your position.
It was amazing.
All right, well, I think it's time. Are you ready to shift, or do you have some more?
No, I mean,
okay.
we can.
This is the fun part. I don't know if you guys know this, but you are now given the opportunity to ask Tim questions. So if you have one, please go ahead and go for it. Yes, Kevin.
Yeah. How do you plan to continue the virtual challenge?
Yeah, well, so the question of where does it go from here and how do you continue a virtual challenge? I think one of the awesome things that we did from the start was make this with open source in mind, to plant the seeds of development. So there's a lot of resources that we've invested in intentionally, even knowing that it will certainly benefit the virtual competition, but it's going to benefit well past. So I'll fill you in on a little secret, I guess. Anything that said SubT challenge, fill in the blank, we knew we were going to need for the SubT challenge. But anything that's removed the word challenge, SubT virtual testbed, SubT tech repo, SubT community forum, that's intended intentionally to live well past the end of the challenge itself. And we did that very, very specifically. So I think in terms of being able to have created that infrastructure, provided the resources, it's my hope that you all and those out there who are interested in this area can carry this momentum. The SubT virtual testbed will remain open, active, and available for a bit of time. And to those who are willing to carry it even further, we certainly encourage that from DARPA's perspective.
Anyone else? Yeah. Oh, it looks like we'll go with Marvel to start, and then Hilario will come back to you.
Were you surprised by the success of some of the top teams and how well they did in some of those worlds?
Yeah, wow. So I think the virtual competition, and Angela, who our virtual competition lead, spent many an hour designing those worlds, right? And the main reason why was because, hey, we needed to use this golden opportunity to vary up the virtual worlds so we can go learn a lot more lessons. So I know verticality or long distances or significant high density, let's jam pack a bunch of artifacts in these areas. What are the key variables that might be interesting? We're only scratching just the surface. So I'd say in terms of how happy I am, absolutely. If you look across the board for all of the competition runs, they're very different in performance. And so I know you're going to go back and look at your logs. We've already done a little bit of that already. And I can say that there are those solutions that seem to work well in some places and not so well in others, but that's different from team to team. So is there something that we can extract from my perspective? Is there something about the worlds that cause those solutions to perform better than others? I think there are a lot of opportunities to tease out some new surprises, and that's what DARPA is all about, is discovering those new technological surprises.
Hilario, I believe you had one.
Is there a chance that we're going to have a technical workshop after this?
Can you ask the question again? Was that, will there be another challenge after this?
No, a technical workshop.
I think we're having some technical difficulties with you, Mario. I think we might have to come back. We'll see if we can iron that out. Does anyone else have something? Oh, we'll see if we can get.
Let's try it.
Let's try it. Go ahead, Wolfgang.
Yeah, okay. I think I have a similar question scenario. So we had not so good results, but we have some good points, some good strategies, some good components in our solution, and we would like to share our experience and our knowledge with the other teams. And we would also like to know what went wrong in our solution. So is there any problem or is there any chance to have a technical workshop where we can exchange our knowledge, our experience with the other teams, the teams in between?
Yeah, sure. So if I heard that correctly, thank you. You're interested in sharing more broadly your results, your approaches, your technologies and things like that, and exchanging with your fellow virtual competitors. I love that idea. I think that's exactly what this is all about. So whether it's in a blog post or it's in a GitHub repository that you release or share, that SubT community forum is another great place to be able to share announcements of things that you're generating. I think there are many folks out there who would love to take advantage of the types of things that you've been able to develop, and I fully encourage that. I think that's all part of the SubT Challenge motto of collaboration will help you accelerate and lead to new inspiration. Yeah, thanks for that, for sure.
Anyone else? Oh, looks like Team Robotica's got one as well.
Yeah, what surprised you most about the outcomes?
Try that one more time.
Let's try that again.
What surprised you most about the outcomes?
I think plans.
What are plans for the virtual testbed?
What surprised you most?
I didn't catch it.
I didn't catch it either, but maybe you can add that to our chat. This is the world that we live in with Zoom. I totally get it, and we can get that read out over here. I think we can certainly do that, but I guess the acoustics in caverns or something
it
that
is
we got to work.
Space, right?
Fair enough.
We got some issues with that.
Yeah, but thanks for the question. So what surprised you the most about the outcome? I mean, truthfully, I'd say the fact that so I tried to scratch some numbers. Of course, I like my analysis. And the combinatorics of being able to mix and match the different types of robots, right? I think it's just mind-blowing how many combinations you can possibly have, even with a constrained budget. So one of the surprises that I'd say is marsupial. I'm really curious. We introduced marsupial platforms knowing that at least on the systems competition, marsupial platforms would be used. We even priced the SubT credits cost trying to give you a bargain. If you get a UGV and you add on a UAV, it'll give you a discount. So I think one of the surprises for me was understanding why does marsupial not work so well in virtual, or maybe there was some other reason why that didn't work out. So I'm going to throw the story back to you, the question back to you. Were there any explorations of marsupial in the virtual domain? And I'm seeing some head nods, so that's cool. What'd you find?
So I'll say that we didn't get to use it in the finals because we wanted to use our Husky model that we were using in the systems competition.
That makes sense.
And we weren't able to get the marsupial version of that in time. But we did do a lot of exploration with that in local simulation environment. And we found a lot of usefulness for that because launching with our limited battery life from the gate, usually the vertical part of the environment was much deeper in. And so having that marsupial capability would have really helped. But we didn't get to use it, but I think it would have been great if for other teams who were able to use that.
Anyone else on marsupials? Go for it.
Yeah, I know a concern for us, we thought about using marsupials, was getting the SLAM, so the simultaneous mapping and localization part for the aerial vehicle, making sure that we could both conserve the battery life on it and have enough computational power to run that SLAM. And we sort of ended up deciding that we were better off getting the whole robot from the beginning. But that's definitely something that we're interested in.
Sure. To go back to the question of what else surprised me, I think, as I mentioned, the diversity of the types of solutions. So there's many ways to explore an environment, and I think there are some methods that many people use, and there are methods that other people use, and things like that. And it was just really cool to see that diversity of solutions. And the reason why that, I shouldn't say it surprised me so much as it, well, truthfully warmed my heart to see that diversity, but the fact that we're still early in the algorithmic evolutions, right? We still haven't converged on the one algorithm to rule them all. You would think that after thousands of simulation runs, millions of simulations runs, we might be able to identify one approach that could work better than all of the others. And while we certainly have those that work better than the others, not the ones that definitively say, this is the one I want to write home to mom about. I still think that we still need a lot more exploration. I would have thought maybe we could have solidified a particular direction, and that just tells us that there's still a lot more to learn. So I think that's maybe an opportunity to keep on pushing the boundaries here.
Now I'm going to go into some final thoughts. If any of you would like to share some final thoughts about your experience with the Subterranean Challenge, this is your time. Anybody? Go for it.
Yeah, so I'll just say Team Barks has been here since the very beginning, and I came on pretty soon after that. And just watching, especially from Tunnel until now, obviously our solution got a lot better, but also just the community really grew, and the test bed, when we started, it was pretty, sort of 90s jigsaw pieces together, and now we have real scans of the environment, and there's fog, and there's all this richness to it. So that's been really great, and it's been wonderful coming to all these meetings and getting to know all of our fellow virtual team competitors. That's really, we definitely have a lot of ideas for future directions based on conversations with people here. So I think really seeing the whole community grow over the course has been really great.
Absolutely.
Hilario, I think you had a comment as well?
Yeah, well, I'll start explaining. So, the reason we started with the DARPA Challenge is because we actually wanted to build the next generation of robotics. And we found out that there were two limitations. There was a hardware limitation and there was a software limitation. Wasn't many robots that could actually navigate in complex 3D environments, and thus there wasn't the software needed to make these robots work. And the SubT Challenge is exactly about this, which was, in the other hand, exactly the things that we wanted to develop. And that's the reason we started in the SubT Challenge. I started alone, working on the Cape circuit, and when we got the third prize, it validated that at least the development that we were doing was going somewhere. And at that point, we used that financing to start a new company, actually, where we are building also quadruped robots. Because it has been shown, I think, pretty well in the DARPA Challenge that if you have an indoor environment that is complex, legged robots can actually do a pretty good job there. And now our idea is that we want to use all the software that we have developed for the DARPA Challenge, which is very aligned with our interests before we started working on the challenge, to actually build this next generation of robots. And from our side, I thought that, and you guys would be happy to hear that one of the first pilots that we're doing next year is with the firefighters of Barcelona. So also helping the first responders that we have here next to our home city.
Oh, that's great to hear. Now that, like I said, it warms my heart to think about the possibilities of the technologies that you've all developed and how we can make that work in the future.
Would anyone else like to add? I think we'll finish off. Tim, anything?
Yeah, I mean, I really appreciate the opportunity, I think, for DARPA to engage with you all. One of the reasons why the challenge is so phenomenal, in my opinion, is that it can reach out, not to just one or two or three different groups, but in fact the whole world. And as evidenced by those who are joining us, whether it's many time zones away or right here in our backyard, I think it's been phenomenal to be able to engage with you. So I know there are many, many hours I would love to know how many source lines of code you've had to write. That'd be a fun little nugget. But I think the types of contributions, like I said, the lessons learned still remain. We have a lot left to learn. So being able to keep up the press to go push on that and to collaborate to be able to do that, not only are robots collaborating, I'm really excited to see where everything goes. So thank you for all of your hard work, many countless nights, probably some good coffee dosage, and yeah, thanks again, everyone.
All right, can we hear it one more time for our virtual teams? And now we're going to take just a little bit of a break. We'll be back at 4 o'clock, and we're going to get on into systems competition. So we'll be back with you shortly.
Thank you so much, everyone.
Thanks, guys.
That was really great. That was really cool.
I think we're done.
Think so.
2, handheld, handheld 1, handheld 1, handheld 1, handheld 1, check 1, 2, 3, handheld 1, handheld 1, handheld 1, check, 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 1, 2, 1, 2, 3, 4, 1, 2, check, check, 1, 2. Square. Check. 1, 2, 1.
Please welcome back to the stage your host, Cameron Irwin, and SubT Program Director, Dr. Timothy Chung.
All right, it's time to get into the systems competition. So I'm going to ask our team representatives from the systems competition to come on up. Beautifully done. It's so nice to see humans.
Yeah, it's
I've been
great.
talking about the robots this the last few days.
Exactly right.
And then again, as a reminder, just if you'd like to speak, go ahead and hold that microphone nice and close to your face. I'll be able to really hear you guys. Thanks for joining us. This is going to be a fun time. Oh, we finally made it. So I'm going to start us off. What were some of the biggest surprises that you maybe didn't expect heading into the systems competition here at the final event? And again, introduce yourself the first time you speak. Who'd like to go first? Tomas?
So I'm Tomáš Svoboda from CTU Krasnodar team. And actually when we first got the info that it will be here at the Mega Cavern, we obviously look at the wiki page, what it is. And we sort of get hooked by the large spaces, large caverns. So we kind of were thinking, okay, now it will be really about kilometers long. So the fact that at the end it was actually kind of compact but very complex maze of narrow corridors with a relatively complicated topology, it was a bit surprise to us. Yeah. That was probably the biggest one for us. Yeah.
Yeah, thanks.
Anyone else?
Yeah, Sean Hubbard, lead for Team Marble. So many nights I stayed up very late, nightmares about what Victor was going to be able to do in the course. But to my surprise, it was actually quite representative of kind of what we were thinking about and what we were planning for.
And what were some of those indications? Because it is the triathlon, right? You're having to deal with so many different subdomains.
Absolutely. So we actually liked the tightness and so the compactness in the environment. We were also thinking a lot about the different types of terrain we'd have to traverse. And so we saw all of that in there, which was just wonderful.
Awesome.
Any other surprises? I'm eager to hear what surprised you all.
This is Sebastian here from Team Explorer. I think what surprised us a little bit is communication was easier than we expected, and the number of objects per kind of square meter was denser.
Cool. Looking forward to questions about that topic, I'm sure, at the end.
Now moving forward in terms, oh, you have something?
Yeah, something to add. Marco Hutter from Team Cerberus. I think from our side, one of the things that we did not expect is that the difference between the two preliminary rounds and the actual final were not that huge. So the environment stayed similar. We were expecting that they'd be completely different thing and something we absolutely did not expect and have never seen before.
So how did that change how you approached that prize round? I know as you kind of got into it and maybe realized maybe it isn't as different. How did you guys deal with some of those? Anyone? Go for it.
So in that time, we sort of, as we got the generous funding for the last 10 months, so we kind of took the risk and opted for a relatively, well, largely new solution. So we abandoned more or less the old one, and we were really up to the full autonomy. And we were so concentrated on developing the new autonomy, so we sort of forgot about the possibility to help the robot by the human. So at the first crossing, we kind of was not really able to effectively tell the robots where to go, because the autonomy exploration has a higher right to overrule the person in command in the certain, well, not completely, of course, but at a certain decisions. So it was, yeah, it was kind of difficult for us. Other than that, yeah, the flying guys that the tremendous job to really send the drones in, even for such confined spaces. Yeah, so we didn't do that much tweaking actually when after we first saw the preliminary run.
Yeah, I think that makes sense. I think one of the things that you're highlighting here is the notion of being able to change configurations and then adapt. So I'm curious to hear, were there any mid-round corrections or changes that you thought about, not bug fixes, but in fact strategies that you might have employed that are different than what you went in with your mission plan, knowing that many of you went in with a plan?
Yeah, so I think our whole perception of what our system could do changed throughout this event here.
Awesome.
You know, being an academic, we've always thought showcasing the autonomy was kind of the primary thing we wanted to do, and all the cool behaviors and all the cool capabilities of robots. But you know, what we got here, we did our first deployment, and you know, I think we realized as a team that may have been subconscious, is that this is a tool now. Like, it's at the level where it's a tool where we can go interrogate subterranean environments. And so we started to change our strategy based on that, and so started incorporating more of the human-robot interaction elements, made a couple slight modifications in code, and really improved our capability. So that's kind of how we changed there.
Yeah, that's pretty cool. Using autonomous systems as a tool rather than as a research entity all on its own, I think that's kind of interesting. Navinda, I'm really interested to hear, especially from many, many time zones away, were there any mid-run or mid-round changes that you saw from Team Cyro Data 61?
Thanks, Tim. So I don't think we made any big changes, but there was a bit of a surprise for us as when it comes to, I guess, the drone unfriendliness of the course. I guess from our experience in urban, we were expecting more areas that would have been, I guess, drone-only areas, and we didn't find that many areas that were exclusive for drones. And the other thing was, I guess we were expecting more stairs and more difficult stairs. So that was a bit of a surprise, but in a way it was a surprise in a good way, I suppose.
Now you talk about a little bit of the destruction that maybe took place, especially for those UAVs, and that was a little bit of a different element here at the finals with that run 1 to run 2 into the finals. There was a different strategy and approach kind of for each of the teams. Can you maybe outline how that approach shifted and changed in terms of taking care of your systems and maybe making sure you make it to that prize round? Did anybody? Ali?
Yeah, Ali from Aliaga from CoStar. I think our strategy changed quite a bit from prelim to from day 1 of prelim to day 2 and to finals. I think one thing changed for us is we were expecting a larger environment, so we were planning to deploy larger number of robots, a larger team, but we realized that a single robot is able to sweep the space, so we don't really need to search for artifacts. We just can see them if we traverse. So we reduced the number of robots. The other big surprise for us was the level of fog. So we even changed and adapted during the run. So in the last day, we had a thick fog at the entrance, so we had to really change and put aside the robots that were relying on vision, and our pit crew amazingly just adapted and sent different team of robots that were able to actually go through the fog. And yeah, so it was a lot of surprises.
Now, is that true for all of you in terms of knowing how dense that fog was going to be and how much of a difficulty? Was that true across the board? Did you expect that or no? Yes, I see Sebastian saying no, yes. Go ahead, Kevin.
So Kevin Knadler, Coordinated Robotics. We certainly expected the dense fog, and so we weren't really prepared for it, but we expected it. But the strategy was, as we adjusted to try and avoid the fog and get our vehicles that could explore and keep their localization working better in avoiding the fog as we saw it.
Now, so many of you have different makeups of your teams, and you can see them out there on the floor as well. And it's really interesting to see the amount of work that's gone in from each of your teams and their perspective. I mean, can you speak to the collaboration within your team and how much work really went on, not just leading up to the finals, but here at the finals? Does anyone have a story to share?
I'll go for that one too. We took a strategy of making sure everyone got enough sleep. We have a small number of people on our team, and so keeping them functional as much as the people functional is more than the robots, because you really have to be thinking as you're going, and as you lose sleep, your effectiveness drops. Robots don't have that particular issue.
Yeah, so for us, contrary to popular belief, it's really difficult to get graduate students not to work. And so our first sort of intention is to work as hard and change as much as possible before we go into something. And I think we did a good job of that at Tunnel. I think for Urban, we tried to really step up and really introduce a lot of complexities in the system. This time around, we took note of that, and we really tried to test a lot. We scaled back some of the things that were in our design solution previously, but I think it ended up being a really good strategy for us.
Just if I may, yeah, I already mentioned it that we evolved a lot. I mean, from the very beginning, because we sort of started as a self-funded team, and we had some kind of a legacy solution that relied on the tele anything with the robots. Yeah, and so we got the new robots thanks to funding. Thanks again for the. And it has also a caveats for us because the last year was quite difficult, so getting the robots in time was almost impossible. So sadly to say, the final round was more or less the first time where all the robots went in a proper form, hardware form, I mean. So we spent too many nights on convincing the robots to work all the radars work and so on. So not that much time in software tweaking, although we did. I mean, we were combating a bit the communication stuff and so. And about the sleeping, yeah, I was very angry about the guys because I was continuously telling them go to sleep, go to bed, and the last before the final run, I really had to really grab them, put them in the car by force, and drive them to home to at least get some sleep.
That makes sense. I think we were talking about the effectiveness of your team members. I noticed one of the things was how you employed your limited pit crew. So as you know, we went from a larger crew down to our 4 additional personnel, and that really impacts the reliability of your systems and the ability to fits around and just use manual labor to fix things. So how did that change? I'm curious to know how impactful that was to your operations.
Yeah, so I think for our team that changed a lot since Tunnel and the previous circuits, where the robots calibrate themselves now, and we just plug in the batteries ready to go, so it minimizes the workload on the operator, and so that's also how we were able to deploy more robots without tying down the operator.
So what if DARPA came back, instead of saying 4, you can only have 1? Would that, I mean, not doing that, I'm just saying.
We're all shaking now.
Yeah, I know. I mean,
$4 million next week?
Where's my boss? I mean, how critical is that pit crew, and are you finding that there's a knee in the curve in terms of what autonomy or what reliability of your systems is affording you in terms of minimizing that pit crew?
I mean, I think just one thing to add maybe is I think the pit crew for us has 2 purposes. I mean, one is to just physically move robots, but the other one is I think we have basically one person plays the role of kind of the higher level thinking, while the operator is in some sense executing, and often doesn't have the mental bandwidth to think about the higher level strategic thinking.
Sure, Mark.
I think on the pit crew level, one of the
Can I comment on
big
that
problems
when I
that
get a chance?
Sorry?
Navindo, we'll come right back to you after we finish up here with Marco. We'll come right to you. Go ahead.
So I think one of the limitations that are there is with the pit crew. We can reduce this, absolutely, but that's just an engineering problem and a problem of money. I think you don't gain anything from that, which is something you can do. Right now, if you want to have a diversity of machines from different labs, you typically want to have a couple of people that are coming also with a different background. Scaling that up to make it deployable in an actual scenario is not really that big of an issue, just an engineering problem.
Yeah, it's an interesting comment. I think I'll provide some insight. If you look at how mine rescue teams compose their rescue groups, it's usually 5 people, right? And they have different roles assigned, like you said, right? Different gradations of what task areas there might be. And so that's kind of the thinking here is if you wanted to employ these types of systems, could a team that has trained a particular way for many, many years operate and work with these types of systems at that reduced manpower? So no, I appreciate those insights. I think Navinda had some thoughts on Pig Crew, especially with telepresence capabilities, I guess.
Yes, apologies because I have a bit of a lag between audio and video, so the time that I react might be a bit off, so sorry about that. I think one of the earlier ones was also about how the team coordinated and about losing sleep and things like that. So as you know, we had some difficult circumstances and we couldn't send our full strength crew over, and that caused a lot of concern for us, especially along the lines of how are we going to deal with it if robots break, because we couldn't send our core mechanical engineering team, the mechatronics personnel, the electronics engineers and all of that, and that caused a lot of concern. And to a point, just a few weeks ago, we were even contemplating not deploying or forfeiting the preliminary rounds, like essentially not deploying any robots, trying to save robots for the final run. But as you know, things worked out differently. The fact that we did do really well in the preliminary rounds was completely unexpected. But what worked out really well was, even though it wasn't the preferred circumstance, having people in the 2 time zones did work in our favor in the end. So we essentially had people that worked 24 hours because we actually had this massive time difference between Australia and the US, and that allowed us for the team that was in the US to upload data logs, and then for the team back here, OpenEye to analyze the logs and then provide feedback back to the team. So that helped, and that way we did not necessarily have anybody losing sleep as such, because we actually had two shifts essentially. So that worked out quite well, and we did do some hardware upgrades and changes during the preliminary runs, but by having identical robots back here in Australia, our hardware engineering team managed to do the troubleshooting and debugging using the identical platforms here, and through our telepresence robots, they were guiding the team that was in the US to replace a motor in one case for one of our track robots, and the crew that was in the US had never done that procedure ever before. But we managed to guide them through. So that worked out quite well.
Yeah, I mean, you mentioned the track robot, and my mind immediately goes to attrition, and in Cyro's case, anyways. And I'm curious. We've always advertised at the beginning of this challenge that attrition is not only possible but likely. So, what does that mean for your robots? It means don't put all your eggs in one basket. I'm really curious how you thought about attrition of your robots and how you dealt with oftentimes the disabling of your robots, whether falling off ledges or whatnot. No pressure.
Okay. I can take the falling off ledges part. So yes, I mean, that robots don't work was a large possibility. Yeah. I think it's not very unlikely. And so one of the strategies we had was this idea of shuttling data. So the robots all synchronize which objects they've detected across each other, and we had this plan of essentially rescuing data of the robots. So the robot that fell off the ledge, we actually wanted to send a drone to get some of its data, but we kind of ran out of time because we had to look for too many objects we had already found. So.
Yeah, that makes sense.
Yeah, I think the structure of the course helps determine that. So if it would have been a very wide open kind of space like the traditional cavern here, I think a lot of robots would have helped. Tight, narrow spaces and places for robots to fail and kind of clog up the interchange there we saw that quite a bit in the challenge. So for us, I think we limited the number. We were prepared to deploy much more, but I think we limited the number to 4, and that ended up working well for us.
Yeah, I think, on that point, I've heard time and again, if you send in a robot for mine rescue and it fails, you've now created another problem for the mine rescue team to have to go in and now is obstructed, right? And nobody wants that. And so understanding the nature of the geometry, I think, is an important thing for sure.
Now, one of the things I would love to do is to hear from each of you about your key takeaway. What's the main thing that you're most proud of, apart from maybe even the finish and your results, but what is the key takeaway from the final event? And I'll start down here with Tomas.
Yeah, the key take home that there's still a lot of work we need to do in order to improve. I think despite being a bit disappointed with the overall result we achieved here, we definitely do not regret. We took the risk and created a new system. I think that we are on the right way, at least as the promising results from the virtual shows, because the system is more or less the same, up to some details. So we are on the right way, and we hope that we will be push our technology further based on what we learned here.
I like it. Sebastian, I'll head on over to you. What was the best thing that happened for you guys? Best development?
Maybe I'll take that next.
All right, send it on over.
I think my favorite part of our finals run, I think we stumbled through the smoke. One of our spots lost localization. And we're trying to get it back and trying to kind of teleop it back and maybe try to relaser it. But it ended up loop closing and got us localization back, so we just sent it back out in the field, right? That's my favorite thing. I think my takeaway, it's a sports metaphor, but you have to practice how you play, right? And so we ended up doing a lot of deployments, and not just doing deployments to iron out kinks, but also doing deployments to practice and get everybody in rhythm, right? And so we were really proud of our team and our pit crew for just getting those robots up and running and sending them right in right away, and so without any issues at all.
And on over to Martin.
Hello, this is Martin Lohi from Robotica, and what I am proud of that we kind of managed actually to get to the finals, to deploy our robots we had, and actually they did the work we expected. So yeah, we are not on the top of the table, but still we scored some points. And the robots run fully autonomously because we tried to port the code which was used for the virtual in both. And actually the algorithms were much more complex than last time, so the articulated robot also managed to navigate in the tight spaces into storage area, which was like a plus. Also, the neural networks reported the artifacts there, but so there is a progress definitely since last year. So I'm glad.
That's awesome. And over to Ali.
Sure. I think the most exciting part that we are happy, I think, is the sheer number of robots. Right? In 2018, in the Styx event, we had 1 robot and 1 rollercopter that went 200 meters. We were really happy, and I think we were not imagining that. 3 years later, we have 11 robots that can explore, multi-kilometers. So that was really exciting. And there was a few moments in final event that 1 robot was stuck and the other robots knew how to pass through and be able to still continue the mission. So I think those were great moments. But in addition to technology, I think the events themselves, what I love about is about the human team, right? So that final push and people working together to try to support each other. you know, you might be a traversability expert, but if artifact team has a problem, you jump in and try to help. That's another incredible thing that, you know, we experience at every event.
And I'm going to head to Navinda.
Yeah, thanks. So there are lots of takeaways for us. Recently, we watched our Sticks qualification video, and it was amazing to see how far we've come in the last 3 years. Things that we simply did not think that were possible, we've achieved. And we are super happy to have ended up where we ended up. Like getting the top score and having that sort of map accuracy, that's pretty special for us. That kind of helps us prove that in a world stage that we actually have that sort of capability. But specifically about the final run, as all the other teams would also agree, for you to succeed, there are so many subsystems that need to work. It's such a complex problem, so you need your communication to work, you need your robots to have good traversability, your mapping needs to be good, your localization needs to be good, your navigation needs to be good, all of that needs to be good, and your object detection and your operating interface and how the human supervisor kind of strategizes and then deploys the agents. So in our final run, we had a case where when we deployed the first quadruped robot, it went down the cave path, and the supervisor lost connection to that robot, and it was not seen again because it went beyond comms. And then later on, the second quadruped robot came back with the data from the maps and the artifacts from that robot. I think the first one was Bingo, so Bingo just disappeared, and then later on, Bluey came back within comms. That's the robot that went down the urban path, so it had gone all the way past the platform and gotten close to Bingo to come within radio range, where Bingo was in the larger cavern right at the end of the cave run. So for all of that to work, I think for us that was amazing, because that's what the system was designed for, and it worked exactly as intended. And to see that in action, to see that demonstrated, that was a huge thing, and that kind of again validated that our technology that we've developed
I can tell
works as intended.
And I can tell you that when that point cloud came in, right? Because you know, we gathered that you were sending in the second robot to go save the data, maybe not save the dog, but you know, be able to fetch that data, and then it exploded the point cloud and filled it out, and you know that, and we saw the same thing with Team Explorer. We realized that you were sending in that drone to go capture that really valuable data, and it's really interesting to think about the value of information and what you're willing to, you know, how you're willing to deploy your team of robots to go do that. So yeah, Kevin, love to hear what your key takeaways are.
Yeah, so focusing on the Proud issue, really happy with the team pulling together with the difficulties of COVID. We typically distributed a robot to each of the students' homes, and so they assembled them at their homes. And so while some of the robots were theoretically identical, the different assembly techniques led to some non-identicalities. And so over the past couple weeks, we've been working on getting them all together, and the team working on it, we actually were able to deploy all 11 ground vehicles we had along here into the system. And so that's really a lot of work from a lot of people to make that happen. So proud of them for that.
Lovely. Not over.
I think we have seen tremendous progress in all these different teams that only in 3 years make this happen, that we have now field-ready deployments and field robotics. There is really something becoming real. And not only here in this DARPA SubT challenge, but also there's many other applications where the technology we have seen in these days is really directly applicable. On a more personal side, I think what is very nice that we've seen here is that legged systems have made huge progress. So at the beginning of that, like lots of these systems were still in an early stage in laboratory environments, and today pretty much every team comes with a legged system, and they perform very, very well. I think we have seen their tremendous progress as well.
Wonderful.
Yeah, that's really cool. So focusing on that, we have 4 technology areas that we like to focus on for the SubT challenge. So I'm going to quickly take a poll and see how many of you think mapping, like perception, let's start with that. How many of you think mapping is a solved problem? Anyone? Oh, okay, cool.
We might claim it's very close to close to being solved.
Okay, all right. And Tomas, you think it's solved as well?
Yeah, so actually I think that the mapping was working very well on our system. I mean, concerning where the robots went, then they delivered a very precise map. So I think that my colleague who is responsible for the mapping will not like it to hear it, but from my point of view, in an environment like that, it's nearly a solved problem.
Okay.
It's close to.
And let's see some debate here, perhaps.
So I think for LiDAR mapping is very mature. I think for some of the things, for example, if you want to scale down the drones to smaller sizes, I think there's still harder problems in terms of getting really reliable vision. And you saw that everybody used LiDAR as a technology, and that works fine if your system is larger, but if you really want to scale it down, then there's still some challenges left.
I think that makes sense.
Yeah, I'd agree. I think the LiDAR aspect of it's fairly well thought of. But if you want a human to be able to reason or a robot to be able to reason over a map, you need some additional complexity in there, semantic labeling and some other types of things. I think that's the new frontier for the perception side, right, is to kind of push forward and make more complex, more cognitive, amenable types of maps.
Sure. What about, we'll pick the other one, mobility. Well, I don't know that anyone will say mobility is a solved problem, but just based on how much we've advanced, whether it be legged or otherwise, any thoughts on the trends, I guess, the slope of how mobility is getting solved?
I would like to second what Marco said earlier about legged robots. I think this particular event showed how mature legged robots had become over the last few years. So Marco and I work together in the legged robot domain, so we have some special interest in that area. But truly, like looking at the commercially available systems right now and how well they perform, I think that it's truly impressive. And in this particular event, we saw legged robots falling, but we also saw them get up. And I think that's one of those key things where which wasn't there 3 years ago.
Yeah, you mentioned, actually, I got a question from one of our stakeholders. The recovery approach of the legged robots is one thing you just mentioned, but what about the wheeled robots? Was there an intentional decision, design decision not to have recoverable UGVs, wheeled UGVs? I'm curious, did that ever come up in discussion?
So for us, it came up as a question, do we add some flippers to basically operate them? But we opted for simplicity and lower CG.
Yeah.
That's the hope.
Yeah, that makes sense. All right.
If I may, that's actually, I think the mobility is not solved problem. For instance, we are really particularly interested in the escape maneuvers for instance, wheeled robot gets stuck somewhere in the deep mud. I always admire the skills of some human drivers to be really able to escape from the mud trap, using wheeled maneuvers with the vehicle. And at least we still cannot do this, and we see this as a kind of open problem.
Yeah. So one thing the challenge kind of really showed is that air mobility, and especially fast, like up-tempo mobility in tight spaces, is very hard based off the vehicles that we saw flying around. But we have millions and millions of species of small organisms that do it flawlessly with much less computational power and everything else. So I think we can certainly learn a lot from biology in applying it to that particular problem.
Sure. Yeah. I mean, I can say that dragonflies with sensor backpacks or bats or whatnot that might have been used in the SubT challenge. I'm really grateful that none of you decided to use animals in your SubT challenge teams, but nevertheless, I think from a computation point of view, I'm curious, how many of you feel that computation was the limiter for you? If you had bigger, faster computing, would that solve a lot of your problems or get you to that next plateau? And my follow-up question is going to be, if not computation, where would you say is the next limiter? Is it comms or networking? Is it the types of sensors you have available? Is it the base platforms that you might be able to use? Curious. Sebastian.
Sebastian, go for it.
So I think sensing is still a limit. Sensors and sensing is still a limitation, and computation was a limitation for us, but we'll always fill up computation. And we basically just have to find a balance. And we can still do a lot. We would be able to deploy essentially the next level of algorithms if computation was better, some semantic exploration or some other things. But the sensing is still a limitation, and like Ali was saying, for example, the fog or something like this is having good sensing is still critical, and the size of, for example, lidars and the field of view is very limited still, and thus the penetration.
Do any of you think that the autonomy that you've been able to achieve and demonstrated, so again, I was able to watch your human supervisor busily doing a variety of different tasks, but actually many of your operator control unit interfaces quite different. And so I think there's some interesting lessons learned there. I'm curious, do you think autonomy will again, solve many of your problems, or have we achieved an appropriate level where we have other problems that we want to solve first? Martin?
Sorry. I think like it was much easier this year, like as we pushed the autonomy that the robots should do its work without the operator. So it's almost bored there, but and it is because we really tried to imitate what was happening in the virtual world. Surely enough, the robots were hitting the walls, and it would be much more reasonable to stop their autonomy. So, but I think it's a reasonable step forward, because this area was small, but if the robots would go several kilometers, you really cannot assure the communication, etc. So the robots will have to do it by its own and return the data back. So, for us, it's the way to go. So, and the operator should be really almost bored, and then collect data. Yeah, sorry.
Yeah, that's sure. Yeah. So, Marco.
So in particular, if you want to move with reasonable speed and a reasonable number of robots, autonomy is absolute key. Without that, there's just nothing. You have one guy clicking around in virtual robots and you move a few meters a minute, and that's it. Yeah. And otherwise, you really have to send them out, come back, and then help interpreting. So supervised autonomy is still, I think, the way to go.
Sebastian?
Yeah, I think one thing we learned after Urban, where we had a lot of communication, first time we actually had good communication was that the operators tended to focus in too much onto the robot, and we had to the operator had to start to develop trust into the autonomy. He wouldn't trust that the robot would go in all the rooms, and so we'd really work hard to gain trust for the operator.
All right, have we hit that point? Is it time to switch gears?
I was fending it off as long as I could, so happy to
All
turn it
right,
over.
now it's time for questions for Tim. Is anyone? Go for it.
So what were some of your favorite moments in the challenge here?
Yeah, so I'll start with the non-technology one. I came down to the team garages and I was chatting, I think, with a number of folks, and the tram was rounding the corner and it was about to embark and bring up a team up to the staging area, and y'all busted out in ovation, in applause. And for me, it brought a warm feeling, right? That here we are, cutthroat competitors, clearly, but still willing to cheer on your colleagues and your friends and offer a chance to learn. So that just means a lot to me personally, and I thank everyone who was able to do that. It's not something that's in the rules, right? It's something that you're able to just do. So that's on my personal front. On the technology side, I think one of the things that was really exciting was seeing the I felt like I could see how you were thinking differently about the problem from sticks and tunnel circuit all the way to finals, right? I could see the greater reliance on saying that your robots are going to go do something while you can attend to other things. I thought that was really cool. I think that's the direction we need to go. I think it's not even about massive numbers of robots. I don't need 20 or 50 or 100, but man, when you can get a handful of robots to do really meaningful, impactful things, and you can leave the human supervisor to go and do other meaningful, impactful things, we saw that a lot here at the final event. That was really, really cool to see, because I think that's going to be the linchpin that offers up great new capabilities going forward.
Go ahead.
Yeah, so I mean, we talk a lot about the technological advances that this program is going to contribute. So those are certainly the near-term things. You know, I've always maintained that the real contribution and the real legacy of this program is going to be all of the PhD students and all of the engineers and everybody that we train here. They're going to go off and start companies, go into academia or go into industry, and they're going to take the knowledge that they've learned here and keep applying that. Right, and so I know in our team we have so many talented and so many wonderfully just brilliant students that we've had a chance to work with, and I can't thank them enough. But anyway, so I hope you got a chance to interface with everybody on that as well.
Yeah, absolutely, and not just academia and industry and government, but future DARPA PMs, right? And we need that so that they can take what they've learned, that planted the seed. It did that for me with the earlier DARPA Grand Challenges as a graduate student, and I think if that's something that comes out of this and they come back and can kick off a future DARPA Grand Challenge of some sort, then the investment is well made. So I appreciate that. Other questions?
So if you're looking back to sticks and think about today,
yeah,
what is the biggest difference between your expectations back then and what you've seen today?
Yeah. Again, the personal story part, I'll say, is I remember when many of you went on the course tour at Styx. And I also remember that you didn't get very far with your robots at Styx. But when you went on that walking tour, I wasn't there, but I heard back briefs of some colorful language being used to describe how hard this course was that DARPA had set up at Styx. And the thing that's amazing about that is at the time you said, we can't do it right now, but somebody believes that we can do it, right? DARPA must have thought that we can actually get all the way back here, and therefore let's rise to that challenge. And I think for me, that's happened here, right? We created this course. You were able to explore most of it, if not nearly all of it. I think that's a testament to how far you've come. On the technology side, again, I think one of the main pride points here is even if you didn't realize what you're doing, you're developing technologies that have components that will help people right now, right? The fact that we didn't focus only on one artifact type, the fact that we had gas artifacts as an example, or RF sensing artifacts, there are people out there who can make use of that small component technology right now. And so the fact that you've been able to push the entire frontier of this technology, but there are many people out here in this audience that's grateful for even just the one piece of technology that you've advanced. That's so meaningful to me. And there are many out there who can't wait to chat with you a little bit more about getting their hands on some of that.
Tomas, did you have one?
If you allow me a small personal question, because I'm asking the same question to myself. I mean, we did a tremendous job to organize all this stuff. I can imagine how hard it was to make it all perfectly working from my viewpoint. It was really perfect. So now it's over, or close to over. What do you feel? More regret or relief that it's over?
That's a good question. Well, no, I'm gonna say, well, certainly some relief, because what this means is that we can point at this time, this date, whether it's next week, next year, 10 years from now, we can point to this date and say, hey, that's what we remember as being a defining moment in field robotics. Right? I am proud that you all will hopefully have a memorable snapshot of time that says for your graduate student or your interns or undergraduates or whomever that this was a turning point in their career for field robotics. That's going to be really cool. So the relief, of course, of being able to provide such an opportunity to all of us, I think that part's relief. And I have no regrets in the sense that we're not done. You know, the challenge is actually not really over. The challenge now is to take what you've done and without the context of a SubT challenge framework, go off and build your own internal challenge construct to continue to press forward with the technology. It's not always easy to do, but my challenge back to you all is, take your technology further, right? You're on a trajectory that's pretty limitless. It's going to be pretty exciting. So no regrets there for sure.
All right.
More questions?
Ali?
Yeah, so the solutions in the competitions are highly integrated, right? Perception, compute, mobility, and all that. And the scoring system, I think, has been elegantly designed. It's beautifully tried to push all the frontiers at the same time. I'm very curious, do you have a framework, a tool? How do you guys translate this score to, these technology fronts, and how do you see, okay, if we change the rules like this, it's going to push the frontier like that? So is that just based on experience, or there's a mathematical framework there?
Well, there's math for everything. Whether or not we understand it, that's a different story. But to answer your question, no, I appreciate the comment about the scoring function. At the end of the day, we looked at what the people who wanted to make use of this technology, what matters to them, and then tried to back out what the kind of the cost function that would best help drive the technology. So from an inverse game theory perspective, mechanism design, you want to design the rules in such a way that you drive it to a particular Nash equilibrium. So getting into some technical stuff, but how can we have done that? And so the scoring function was designed to do that. From that, however, there are probably, and I've got the list, I look forward to sharing it with you all, of probably about 40 different metrics that we're interested in. So the people who we want to develop this technology for, they care about getting actionable situational awareness. That means sending back information about these types of reports. But how do you do that? Well, generate good maps, have good mobility means speed of traversal, so that's another metric. Being able to have latency in your communications, that's another metric that comes from the scoring function as well. And then, of course, the autonomy, so the number of decision points. So I can share that we constructed the graph representation of the finals course and looked at how many decision points your robots are likely going to have to make. And so if you're using depth-first search versus breadth-first search, that changes computation and how you think about solving this problem. So of course, we're getting in the weeds, which is kind of fun, of course, as well. But I think at the end of the day, we want to answer the question that delivers the capabilities to the people who need it the most.
Now it looks like we also have a question from Navinda. So the question would be, we didn't have a cave system, competition. Where might that have been? What can you tell us?
Man, so there are a lot of caves in the United States and, of course, worldwide. And I can only say that we've visited just a handful of them. What I'll say without giving away the specific answer, of course, is that being able to find a cave that affords us the opportunity to test in a way that we would find meaningful. I mean, many of these places have tiny little holes, horrible staging area. Other places are large and cavernous, but they're only 200 meters long. And so finding the Goldilocks solution of a cave, I think, was really interesting. Now, the cool thing is many of you found caves on your own, right? I've seen. And so I think we actually benefited. In some ways, the silver lining of not having a cave circuit was it shifted the onus on all of you to go find caves that would work for you, and I think that worked out marvelously. So appreciate the initiative it took to go out and to find some real-world caves.
Thank you, Tim. I do have a quick comment on something that you mentioned earlier about the intentions. behind setting up this challenge to really drive innovation and then prompt teams and the participants to advance technology. So I would like to thank you and DARPA for that, because we actually have done that in our lab. So I guess with some similarities to DARPA, we come from CSIRO. So CSIRO is Australia's National Science Agency, and then our mission is to provide research-based solutions to real-world problems faced by the community and the industry. So we definitely have matured and technology through this challenge over the last 3 years, and one of the best examples is our challenge partner Emerson, who spun out from our lab, and now they actually do have a commercialized solution. They do sell the hover map technology, for example, that provides SLAM and mapping and autonomy in a package, which is commercially available. And then that's technology that was matured over the last 3 years through this program. So I think to that end, we kind of achieved one of the goals that you have set.
Sebastian, go ahead.
Yeah, so I have a lighter question.
Oh.
So in the urban, also here in the circuit, we saw some pretty evil flying obstacles, like hanging streamers or paper and so on. Was that on purpose or unintentional?
Yes. No, I mean, again, the real world doesn't need DARPA to come in and make it that much harder, right?
Sure.
So I think, but the point, I guess, is, you know, again, we're trying to recreate these really realistic environments and offer up challenges. And you know, I didn't know that paper would get, you know, flown up and then fall down into rotors. You know, that wasn't. As much as DARPA would love to be able to move, you know, things from afar like that, we didn't do that intentionally. So, but that is what you would find in a warehouse like that, right? So, yes, DARPA is interested in making sure that the bar is really high for you all, which is great. But the real world tends to make that bar pretty high on its own.
Does that mean CSIRO should have gone after Explorer?
We're going to move on. Go ahead, Sebastian.
The paper was replaced.
Yeah, that was next.
There you go. There you go. I believe that's about all the time we have. So at this point, myself, along with all of our team representatives, are going to exit the stage. And Tim,
yeah,
it's
I'll
all
take
you.
it from here. Cool.
All right.
All right, thank you, Systems. I think what you've heard this afternoon, just in this informal conversation, it speaks to the type of impact that we're interested in from DARPA's perspective of being able to develop advanced technologies and prevent and create technological surprise. And I think one of the things that I'm really proud of is, of course, the technologies themselves, but also on a more personal note, you know, all of the impact that we've had we have had over 300 people here just joining us amidst the pandemic. I think what it's taught me is that there are so many things that we can get done when a community is created. So on that front, I am both proud and privileged to conclude the DARPA Subterranean Challenge. As I said earlier, I hope this does not mean that it's the end of all of the innovation, all of the energy, all of the excitement that you've been able to bring to the table. I also hope and even encourage you to go ahead now that you've developed this capability, to go and reach out to any of those end users, any of those firefighters, any of those first responders, and find out really what they really need, right? Is there some little deviation of what you've developed that will make a dramatic impact on what they can do? So with that, thank you, everybody. I'm going to give a very special thank you to all of our DARPA staff one more time, their loved ones and family and everyone who've also helped contribute to all of this. Let's give the DARPA staff one big round of applause. And with that, keep up the press, go do great things, and congratulations on finishing the DARPA Subterranean Challenge. Thank you very much, everyone.